Okay, let's move on to double replacement reactions. The double replacement reactions are the double dates who switch their mates. So you'll recognize these when they have ionic compound plus ionic compound produces ionic compound plus ionic compound. They notice that these are the double dates who switch their mates. Well, there's nothing wrong with the combination that was in the reactant. That's stable, but the product is more stable. That's when these reactions are going to take place, when the products are more stable than the reactants, okay? Not that there was anything wrong with these reactants, they're just better off this way. I don't know if you recognize the cartoons or not, but this is Fred and this is Wilma. These are the Flintstones. And the Flintstone cartoon is set in prehistoric times. And
yeah, but
this,
what did you write it down on the notes? Like, are you expecting us to copy that down?
no. This
okay, so why?
The Jetsons. And so I want you to know that it's not going to be random. That when we're taking the positive and the negative ion, it's not random. That there are some combinations of ionic compounds that are more stable than others. So the Flintstones and the Jetsons are in completely different time frames. The Jetsons are from the future. So what are we actually going to do? We're going to take a look at what the ions are, and we're going to figure out their charge. And then we're going to swap the partners. And when we swap them, yep, we're going to do outside, outside with inside, inside. So Fred is going to go with Wilma, and Mr. Jetson is going to go with, I forgot her name. I forgot to look it up during lunch too. Here's an example. Remember that we're going to do outside, outside with inside, inside. So blue with purple, here's your new compound, and red with green, but write the positive ion first, okay? But before we can know who's going to go with whom, we have to figure out what the ions are. Let me show you what this is. Aluminum chloride is made of aluminum that has a +3 charge and chloride that has a -1 charge. Since +1 and -1 don't already cancel, the formula for aluminum chloride is AlCl3. So when you swap, drop, reduce, your formula for aluminum chloride is AlCl3. Then it's reacting with magnesium sulfate. Maybe I'll put that up here. Al + 3, Cl - 1 equals AlCl3. I want my L's to look, not to look like iodine, so I'm going to write those in cursive. For the magnesium sulfate, when you're writing an ionic formula, you look up the charge for the magnesium, you look the charge for the sulfate. If these two charges already cancel, then you don't have to do anything else except put them together, okay? But before you can do swap, drop, reduce, or you have to know the charge. And before you can figure out what the compounds are going to be, we have to kind of know what's up. So I'm going to put together aluminum and sulfate. But aluminum has a charge of +3, and sulfate has a charge of -2. So when you do the swap, drop, reduce, your formula is going to be Al2SO43 because you have to swap, drop, reduce. Your other compound, when you do inside, inside, will be magnesium chloride. So when you write magnesium chloride, you have to have their charges, and then you swap, drop, reduce. What you end up with that's right here is an unbalanced equation. This unbalanced equation is called a skeleton. That cartoon doesn't belong here. That's a single replacement cartoon. So this is a skeleton equation. How you get the skeleton equation is by getting the charges on the ions, and then you'll trade them off, outside, outside with inside, inside, and then swap, drop, reduce. After this, then you can balance the equation. So see how it needs a lot of room? Let's practice. I'm going to call it example 1, and on my scratch paper, I'll call it example 1 here. So I'm going to start with a word equation. In a word equation, I'm going to do one of these things where I'm going to have the words, and then I'm going to switch the words until I can make the products. So the word equation for this one here is calcium chloride plus this thing here, which is silver nitride, and now I'm going to predict the products. The products are going to be outside, so calcium nitride and the other product, when I do inside, will be silver chloride. Okay, here's my strategy. We're going to take the question that was given and we're going to write it as a word equation. Notice that this doesn't have any products because that's your job, is to predict the products. To predict the products, you do outside with inside. When you write the ionic compounds, don't forget always that the positive ion always goes first. So now, what ions are involved? Okay, let's figure out the ions. So calcium is an ion with a charge of +2. It's in group 2. It has a charge of +2. This ion is chloride, and chloride is a halogen. It has a charge of -1. So the formula for calcium chloride is CaCl2, because you have to swap, drop, reduce to get this. Notice that I did this part of it without thinking anything about these other ones. All I did was figure out the ions, and then you swap, drop, reduce. This is an ionic compound. It's made of the ions calcium and chloride. They have different charges, so we had to swap, drop, reduce. Okay, next one. Next one is silver nitride. Mrs. Cron, do you have to do that? Because it says silver nitride right there. Well, it's already there. However, I want you to pull that apart because we're going to be moving this stuff around and you need to know what the ions are. So let's write out the ions. Silver is an ion with a +1 charge, and nitride is an ion with a -3 charge. When these get swap, drop, reduce, you get this. So that means that you can do this backwards and get the charge on the ion in case you forgot. There is another way you could figure it out. If you don't like swap, drop, reduce, you could check out its placement. Silver is a special guest. It always has a charge of +1. Nitride is in group 5A. It has room for 3 extra electrons, giving it a charge of -3. Okay, so notice that I didn't pay attention to anything else. I just figured out what was the charge on the silver, what was the nitride, what are the ions. This step right here, I need to know what ions are involved. Now on the other side, we're going to be combining the ions. That's the whole point. Calcium and nitride will be my next combination. Calcium has a charge of +2, and nitride has a charge of -3. Since +2 and -3 don't pay attention to this. Since +2 and -3 don't already cancel, you'll swap, drop, reduce. Swap means to trade. Drop means to lower it from top to bottom. And then reduce means that you're going to reduce the ratio. This is a 3-to-2 ratio, so it's already reduced. Okay, does this make sense with the swap, drop, reduce? I'm doing the skeleton equation. I'll balance later. I know the calciums aren't equal. I realize that. Okay, a skeleton equation is not balanced yet. Okay, let's figure out the next product. The other product is silver chloride. So let's figure out the formula for silver chloride. Silver has a +1 charge. And chloride has a -1 charge. +1 and -1 already cancel out. So we're going to put them together. We're already done. That's silver chloride. This is called the skeleton equation. The skeleton equation is unbalanced. And once you have a skeleton equation, then you can go back and balance the equation just like we were doing here. Now we're going to fill in the blanks. You see how we have a double replacement reaction? Double dates who switch their mates. We figured out what the new mates would be, right? We figured out what their new partners are. Now that we did that, now let's go back and balance. So normally I would just fill in the blanks, but I want to emphasize that this is the next step. The next step is to balance the equation. I just rewrote the equation so that I can balance it now. Okay, the last step is to balance. So I'll start with calcium because they're on the left. 3 of them came out, so 3 of them will go in. 3 times 2 is 6 chlorines. So I'll put a 6 here so I get 6 chlorines. That'll also give me 6 silvers. So right here I need to multiply by 2, so I get 6 silvers. That gives me 2 nitrides. That's good, they have 2 nitrides, so this is a 1. Now I'm done. What just happened was when somebody said, hey, well, what will you get when you combine calcium chloride solution with silver nitrate solution? And I'll be like, hey, I get calcium nitride and I get silver chloride. Now at this point, maybe one of them is a different color. And I could use some other skills in a little while to figure out which one is which. For today, this is enough. Okay, so when you predict the products, your products are going to be calcium nitride, swap drop reduce, and silver chloride, swap drop reduce, and then you balance the equation last. Okay, this is a skeleton equation, and then you balance. Notice that when I wrote these out here, I'm predicting the products. You do not worry about the number except for swap drop reduce. You do have to swap drop reduce to get the products. You would then balance after you get your skeleton done. Question on that one? It's okay if you take a screenshot. Okay, let's move to the next one. Example 2. Now this one says a new word, aqueous solution. Aqueous means that the substance is dissolved in water. Well, that's good because the solids don't react with each other. They have to be dissolved in water anyway. So let's start with a word equation. In the word equation, we're going to write the reactants and products in words. Copper 2 phosphide and sodium oxide. Now let's predict the products. We're going to take outside outside with inside inside. So the first product will be copper 2 oxide. And the other product will be phosphide sodium. What's wrong with phosphide sodium? That doesn't sound right. When we name it, we're always putting the positive one first. So the metal has to go before the non-metal. So that's why this is sodium phosphide. You'll do outside outside with inside inside. This is called a word equation. All we did was figure out what my products are. Okay. Next, let's make a skeleton equation. In the skeleton equation, I need to know what are the ions. So the ion present in copper 2 phosphide is copper 2. That means copper with a +2 charge. And phosphide, IDE. When it ends in IDE, it means it's monatomic. Here's the charge because it's a group 5 nonmetal. So the charge is -3. +2 and -3 don't already cancel, so I'll have to swap, drop, reduce. I take the 3 from the phosphide and make it a subscript of copper. Take the 2 from the copper and make it a subscript of phosphorus. And that's it. Now let's do sodium oxide. Sodium is Na. It's a group 1 metal, so it has a charge of +1. Oxide is, of course, oxygen with a -2 charge. If the charges don't already cancel, then I got to swap, drop, reduce. So I'll need 2 sodiums to balance out that oxide. Now let's keep going. We're going to do the same thing. Take the charges, take the ions, and we're going to determine if the ions need charges or not. So copper 2 is copper with a +2 charge. The oxide is O with a -2 charge. +2 and -2 already cancel out, so let's just put them together. And the next one is inside. So I've got that sodium ion with a charge of +1 and the phosphide ion with a charge of -3. So these don't already cancel. We need to swap, drop, reduce. Na3, P1, but we don't write ones in chemistry. This is a skeleton equation. It's unbalanced, but all the formulas are written correctly. Now we'll balance. When we balance, we're going to fill in the blanks with the coefficient. I see 3 coppers went in, so I need 3 coppers to come out. I cannot put a 3 on the subscript. That would change the charges and it wouldn't make it balanced anymore. So you have to balance with the coefficient. 3 coppers went in, 3 coppers come out. That also gives you 3 oxides. So I'll put a 3 over here so I can get 3 oxides. That's going to give me 6 sodiums. So let me check the sodium. 2 times 3 is 6. That's also going to give me 2 phosphorus, which is already here. So good. And we're done. After you balance, then you're done. You do a word equation first, figure out your ions, recombine your ions to make stable compounds, and then you balance the equation. Let's see if I can do this without needing a ton more room. Let's see if we're getting the hang of it. Do we know that, let's see, we need to write iron 3 sulfate. So do we know what iron 3 means? It means iron with a +3 charge. Do we know what sulfate means? That's SO4 with a -2 charge. So I'm going to swap, drop, reduce. The iron is going to get a 2, and the sulfate is going to get the 3 on the outside of the parentheses. And it reacts with potassium chlorate. Let's see, potassium is a +1. chlorate is a polyatomic ion. It's ClO3 with a -1. Positive one and -1 already cancel. So KClO3. Now let's do outside with inside. One of my products will be iron 3 chlorate. Fe with a +3, ClO3 with a -1. I'm going to need 3 of these, and then I'll get rid of the charges. And my other compound is going to be the potassium sulfate. Which is K2SO4. Now, skeleton equation is unbalanced. That's okay. We'll balance it with filling in the blanks, filling in the coefficients. 3 sulfates went in, 3 sulfates come out. 3 times 2 is 6 potassiums. Got it. That's 2 irons, and 2 times 3 is 6 chlorates. Good, we're done. It's not that any one step is hard, it's that there are so many, right? It's not like you don't know how to write ionic formulas, it's just been a while. And we might need to have you brush up on some of those patterns. The pattern is to think of the word equation first, then think of your ions, then you do swap, drop, reduce. I should add that in here. Swap, drop, reduce to get your formulas. And after you get all your formulas, then you balance the equation. Balancing has to be last. Okay, the combustion reactions always have some kind of fuel, and it combusts in the presence of oxygen. And the combustion reactions will always produce carbon dioxide and water. So there's your skeleton. And then you have to balance the equation. Okay, it'll have some form of a fuel. When it's burning reactions, combustion means that it combines with oxygen. And the products will always be carbon dioxide and water. I'm going to stop the recording so I can make some announcements.